Okay, so now we're going to do question 10. We just did question 9 from the previous video that I did. If you haven't seen it, just look in this video, this description, sorry. You'll be directed to the previous video that I just did for question 9. Now we're going to do question 10, same paper of 2021. Just going to go through this question without a rush, so please bear with me. I just want to make sure that we all understand. So what we have here is BE and CD as diameters of the circle M with center M, right? And we are told that chord AE is drawn to cut CD and AE is perpendicular to CD. We're also given that angle C is equals to X. So the information is given in the diagram, but just make sure you underline that info to ensure that you didn't miss anything. Now let's just look at the question. 10.1 says that give reasons why AF is equals to FE. So what is that? Let's see. AF, let me just underline that. AF, I think it's this one, right? Yes. And then FE, I'm just gonna use different color. So we are asked to identify why these sides are equal, right? Why these two sides are equal. If you remember very well in theorem 1, which I did in other previous videos where I explained all 7 theorems. So in theorem 1, we're having this line here, which is a chord, and then we're having a perpendicular line to the center, right? Center O, and then there's a right angle here indicating that it's perpendicular. So this is A, this is B, this is C, right? And what you need to note is that if you're given the perpendicular line, you were asked to prove that AB is equals to BC, right? And you're going to prove that using congruency, right? Okay, fine. So, or sometimes you'd be given a circle like this, and let's say this is a circle. I know it doesn't look like one, so let's say you're having a chord like this and then a line going like this, and you're given that these two are equal, right? And this is your A, this is your B, this is your C. So you are asked to prove that they are perpendicular. So you're only proving the perpendicular part here. So you're always the center, right? So I hope you can recall this theorem. It's theorem 1, and its inverse, right? Or you can call it theorem 1 and theorem 2. It just depends on which book you're using. So this is the same thing that applies here, because we're having this point here going to the center, right? This is the center of M, right? And we are told that this part here is 90 degrees, meaning that this part will also be 90 degrees and this part will also be 90 degrees, right? So basically, this one, if I were to construct a line like this, this theorem is basically going to be this one, right? Right, where we are proving why are these actually equal, right? When you are given the perpendicular angle. So the reason why they are equal is because of the line from the center. So if I were to just write the reason, line from center, which is this, I'm just going to indicate the center, the line from center, which is FM, right? That's the line from the center, is perpendicular to AF, right? So it's perpendicular to AF, right? You can write that down as the answer. AF is the chord, right? It's your chord. Or yes, perpendicular to AF, or you can just say it's perpendicular to the chord, because AF is not the chord, it's just the entire AE is the chord. Sorry about that. So yes, or you can say it's perpendicular to the chord, which is A, E, right? So that's how we are proving this question here, or giving a reason rather of why AF is equals to FE. So let me just erase this quickly and then we do another question. So now we're gonna do question 10.2. 10.2, they say determine by giving reasons the size of M1 in terms of X, right? Excuse me. So we want M1, this angle here. We want to identify the angle here. So for us to identify this angle, firstly, let's just visualize. What can you see? You can pause this video and just identify how can you how can you tell the angle of M1 in terms of X, right? Just pause this video and think. But if you take a look, we're having this part here, this radius, and this one here, right? And then it goes outside to the circumference. So you see it started from the center and then it went to the circumference. So it's theorem 3. I hope you guys can tell now. Theorem 3. Angle from the center of this one to the circumference, right? So that's the first part. We can say M1 is equals to angle A1, right? Angle at center is equals to twice its circumference. So why am I just focusing on this is because I want to identify M1 in terms of X. And where is X? X is here, right? So hence I'm taking this angle from the center to the circumference so that I can be able to use that X, you see. So now that we've done that, we can use the triangle ACF, which looks like this. It's this triangle here that looks like that, right? And we are having A here, which is 1, and F, which is 90 degrees, and C, which is X. So we're going to use this triangle here to identify angle A1. Okay, this is the angle A1, right? So angle A1 plus angle C plus angle F should give you 180 degrees, right? Reason, sum of angles of a triangle, right? So, and then A1, we are looking for A1 plus C, it's X, plus F, which is 90 degrees, so it's equals to 180 degrees. Then we transpose these two here, so we have A1 is equals to 180 degrees minus 90 degrees minus X, and then A1 is equals to 90 degrees minus X. So this is the angle for A1, but you're looking for M1. Remember the relationship between, okay, hope you saw this mistake here, it's twice A1. Yes, I just corrected it. M1 is equals to twice A1. Sorry about that. So now you remember this reason. M1 is equals to twice A1, right? So which means now the answer that we got here, we can simply substitute it in A1 to find M1. So you can simply say angle M1 is equals to twice angle A1, and then 2 into 90 degrees minus X, and then these two multiply everything that is inside, we have 180 degrees minus 2x, right? So that is your angle M1, right? So yeah, that is all for M1. We are done answering the question. Let me just erase everything here. So I hope everything makes sense, especially with regards to this part of the question. If you don't understand, you are more than welcome to ask by simply writing down your questions in the comment section below. If you haven't subscribed, please subscribe. Really appreciate it. My birthday is in December, so that would be a birthday present. Anyways, let's go to 10.3. Prove by giving reasons that AD is a tangent to the circle passing through these 3 points here, right? So let's go and first identify AD. So AD, it's this line here, from this point all the way up to this point. So let me just indicate with the line. Cool. And then we are told that it passes through a circle with points A, C, and F, right? So the points of the circle is A, C, and F, right? So now, for us to prove that AD is actually a tangent, we need to think of a tangent in a circle. What happens? What really happens? What normally happens? If you remember, I can't recall the theorems. Theorems. I would say it's theorem 6, but with books are different, so I can't really say it's theorem 6. Just pardon me if your book says it's theorem 7. But if you have a triangle like this, and then you have A, you have B, you have C. Normally, with a tangent, we would have maybe a line going like this. Just making an example. And this is B1, right, and B2. So this angle here will be equals to this angle there, right? So it's tan chord, right? So tan chord theorem. So normally we use a tangent for tan chord theorem, or when it's perpendicular to the radius. Those are some of the properties that we normally use the tangent. So why am I doing this? I'm trying to show you that that's what we are looking for. We are looking for such characteristics. The angle must be subtended by the chord 2. So basically what I'm saying is this angle here, A2, must be equals to C. You can't just say they're equal because you haven't proven that. So you have to prove that they're equal. How? Which means you must identify the angle of A2, sorry. If A2, so if angle A2 is equals to X, then AD is a tangent. Just note that statement. If A2 is equals to X, then AD is a tangent. So let's prove that it's actually equals to X, right? We already know A1, right? If you remember clearly, we already know A1. We don't know A2, right? We don't know A2, so let's just find a way to create that relationship between A1 and A2, right? So what we're going to do is this. We were told in the statement, I just want to take you back to the statement, that we are having BE and CD, which are diameters. So this statement is critical for helping us solve this problem. So BE is a diameter. Where is BE? It's this one here. So if you miss the statement, you won't be able to solve this problem. So now, BE is a diameter, right? Meaning that this is 90 degrees, right? But let me just remove it. But we know that BE is a diameter, right? So meaning that angle A2 plus angle A3 is equals to 90 degrees. But we're not looking for that statement. We're looking for the other part of the diameter, which is CD. This one here. Because why am I saying that? We want A2. We don't have A3, so we can't use this portion. So we need to identify a section where the other angle is there, but we are looking for A2, right? Hence, I'm just going to use this other diameter, or I don't know how you pronounce it, but yes, diameter. So this is another diameter, and here it's 90 degrees, right? So meaning angle A1 plus angle A2 is equals to 90 degrees. So you're going to write your reason for that, which is you can say diameter. I mean, no one will just mark you wrong if you say that, but we all know it's angles on semicircle. So if you say diameter, must be specific. Which diameter are you talking about? Are you talking about BE or are you talking about CD, right? You can say diameter CD subtends an angle of 90 degrees as your reason. You can just be more flexible with your reasons, Don't try to cram the reasons that you are being told in class, or just be flexible, but just show that you know your stuff. Anyways, A1 plus A2 is equal to 90 degrees, right? So this is so we already know A1, right? We already know A1. We're looking for A2, and remember, A2 must be equals to X. We're not going to force it. We're just going to see if it's going to be equals to X. And if it's equals to X, then you've proven that AD is a tangent, right? So A2, but angle A1 is equals to what? We found that in the previous question. A1 is equals to 90 degrees minus X. So the reason for this, you can simply say proven in previous question, right? You can write that down, doesn't really matter. So now you're just going to say, okay, fine, A1 plus A2 is equals to 90 degrees. Here it's 90 degrees minus X plus angle A2 equals to 90 degrees, right? So we transpose these two here to the other side. We have angle A2 is equals to 90 degrees minus 90 degrees plus X, right? So angle A2 is equals to, so these two subtract each other, you remain with X. So therefore, angle A2 is equals to X. So as I said, now we've proven this statement, right? Angle A2 is equals to X. So therefore, AD is a tangent. So you have to state a reason. Once you've proven that something is whatever the question wants, if it's a tangent or if it's a cyclic quad, at the end you must put a reason for that. So here you can say tan chord theorem, right? You've used tan chord theorem, not directly, but you've used tan chord theorem to prove that this is actually a tangent, or tan chord theorem explains this, So anyways, let's move on to another question. We are done with this one here. Let me just erase this quickly. So I hope you guys do understand and everything is making sense, because that's the whole purpose of this, is for everything to make sense, so that we understand Euclidean geometry. I know it's one of those challenging, if not difficult topics, but you'll understand. Know your theorems, know properties of your polygons, then you'll be fine. Now 10.4, we are given that CF is equals to 6 units. We are given that AP is equals to 24 units. We calculate with reasons AE. Fine. So CF, let me just write here. CF is equals to 6 units. Right, so you see, yes, CF and AP is equals to 24 units. AP equals to 24 units, right? We're required to find AE, right? Is it AE or AF? AE, the length of AE, right? You're looking for that. So what you can do is this, you can write here, it's 6 units, right? Let me use a proper color. This would be 6 units, and AB is 24, right? So now there's many ways to calculate. We all know that. So this is not one way of solving this problem that I'm going to use. There's many ways that you can identify to solve this problem, so please note that. Anyways, what I'm seeing here, as I said, you must know your properties. Properties of all the theorems, properties of your polygons, properties of your midpoint theorem, your similarities, all of that. Just know those properties so that you'll be able to apply them when solving these problems, because that's what I'm going to apply here. I can see this triangle. I'm just going to draw it, or I'm just going to highlight it. This triangle here. If you take a look at it, even though I'm not drawing it properly, but just want to show you something. Take a look at this triangle AEB, right? You can see that FE is equals to AE, right? We've proven this in the previous question, right? That FE is equals to FE is equals to AF, right? We've proven that, and I told you that this is from theorem 1. And then this is the center, right? So if it's a center, this side also, this side is equals to this side. Why? Because it's a radius, right? Maybe you can write that down. You can say in triangle AEB, right, AF is equals to FE, and EM is equals to BM, right? So you can specify the reasons. This one you can say equal radii, right? And then this one here, you can just say proven. We've proven this in the previous question, right? You can just say proven. Fine. So why am I using this? Is because if you remember your midpoint theorem, it says that if this side here is equals to this side here, right, and this side here is equal to this side here, therefore this middle line is going to be half this one here. So that's where I'm going with this, which will help us find this AE, right? Why am I using this? Is because FM, we're going to be able to identify FM by doing that, right? FM, because we already have AB, right? So FM. So what I'm saying is FM is equals to half AB, of which AB is 24, right? So which means half of 24 is equals to 12. We write 12. So the reason for this, so you can say midpoint theorem, right? Midpoint theorem. So now you know here it's 12, right? So once you have this, then now it's going to be a bit easier, right? Because you have this portion as 12. Let me just indicate a different color. This portion here, it's 12 now. And you're looking for FE. You're looking for FE and AF, the combination of the two, right? So you're having you've done these type of question actually, but it's probably not easy to see that you've done them when you are solving your theorem 1, where you had this here and this here, where you're given. So now you know this is 12, right? But you don't know from E, and then here it's F, and then here it's A. So we don't know this size here, but we know that from this portion here of the circle of M to this point here of F is 12 units, right? And we also know from F to this portion here it's 6 units. So you can see that you've actually done this problem. It's just that when it now comes in the exam, it looks different, right? So we now know this. And what does this help us with? It tells us that this, from the center to this point, it's a radius, right? Meaning this same portion is equals to this part here, it's equals to this part here, right? Because it's a radius from this point to this point, and to this point, and to this point. So you can simply say, okay, if this portion is C, so you can simply say ME, which is this portion here, which is this, let me just indicate it, 1 is equals to this part here, right? ME is equals to MA, right? It's equals to MC, right? But what is MC? MC is equals to the combination of 12 plus 6, which is 18 units, right? So if it's 18 units, this combination, which means this is also 18 units, which means this is also 18 units, right? And how does that help us? So once we know that this is 18, and this is 18, and this is 18, then it's easier for us to find the length of AE, right? Why am I saying this? Let's do that now. So now we know that it's 18, 18. We can simply choose one triangle. We can say triangle EMF, right? Which looks like this. It looks something like this. This is right angle. This is the 18 that I was talking about. And this is EF. And this is 12. So now we just want to identify this one here, EF, right? Because the combination of EF and FA is equals to AE, right? So we're going to use Pythagoras in this one. So we're going to say, okay, let me indicate this is M. So EM squared is equals to EF squared plus FM squared. So here is 18 whole squared is equals to EF squared plus FM, which is 12 squared. So EF squared is equals to 18 squared minus, because we're going to transpose this to the other side, minus, so it's 12 all squared, and then you put the square root both sides. EF is supposed to give you an answer of, let me see what I wrote here. So it's supposed to give you 13.416 units. Yes, this is what you need to get. And then now, so I mean EF, let me just indicate here, EF plus FA is equals to EA or AE, right? So why not multiply this EF by 2 to get EA or AE? Is equals 2 times the 13.416, which should give you an answer of 26.83. So it's 0.83 units, right? 26.83 units is your length of AE. So I know it was long, but hope you did understand. If you didn't understand, as I ask again, please write down your comment below. Yes. Now I'm going to do another follow-up question from this one. Remember, this is 2021 November. I don't know how many question papers I'm going to do. Probably this is just the only question paper I'm going to do because I'm tired and I'm also writing exams. So yes, if you don't know my name is Teniso Lamini. I'm a student at FETS doing engineering there. So hopefully we'll see you guys next year on campus. So as you can see, this is the question 11 that I'm going to do in another video. I just don't want to do it in this same video because of the length of the video. If you want to know this portion of the question, please look in the description of this video. You will find the link for the follow-up question.